Alright, so create our sketch again on any plane. We'll do our center rectangle and we'll put our smart dimension on it, 350 by 150. And we'll exit the sketch and we'll extrude it 10 millimeters. That looks good. Okay. The next command then is just our hole wizards. So we'll do our hole wizard. We're doing a tapped hole, and we're doing an ISO standard, and it's a bottom tapped hole, and it's going to be through all M6. So what we can actually do there is it's good practice to have a near side countersink on it, something like 6.5 or 7 millimeters. Okay, so the threads below the surface of the material is always good. So we do a position here, and what we can do is, because we want one in each corner here, we can select the position. Don't touch any of these options, we'll cover them again. Just pick the face and just put one hole in the corner and go straight up the smart dimension. And you have two options. If you want to just put a hole in, let's say for example 15 millimeters from each corner is one way of doing it. These are only for feet or something like that, so they're not that important. Okay, and if they're in 15 millimeters from each corner, it means if you make the plate bigger or smaller, the hole will always be 15 millimeters from each corner. And that's all I do there. Okay, I can accept that there now, and I can have one 6 millimeter hole tapped. All right, I can't see the threads on that. If you want to see the threads on that, you just go to settings. Okay, you go to document properties, detailing, and shaded cosmetic threads. And now you see the shaded cosmetic threads in the part. Okay. Now the next thing I want to do is I want to take advantage of symmetry. So I have these two work planes here that I can use. So if I mirror this hole across here and then mirror it down here. So SolidWorks now allows you to mirror, okay, using one plane. Okay. So if I pick the features I want to mirror as that hole, so you see I've selected this front plane and it's mirrored it here. I can do a secondary plane, which is this one in the middle, and now it mirrors it twice. So it mirrors the mirror, which gives you the 4 holes, and you know they're 15 millimeters in from each corner because I've kept the plate in the middle the whole time. So I have the two work planes in the middle of the part. All right, and that's kind of critical there. All right, so I've taken full advantage of symmetry there, which is really good. All right, so our next week command is a hole wizard, and I'm going to do a tapped hole again, and let's say it's M6. It's for the bearing blocks that we were doing. So again, I just check what size it is, but I think it's M6. So this time it's a wee bit different. I'm going to go position, and I'm going to select the face. All right, and what I'm going to do here is I'm just going to put 2 holes down at the moment. All right. And then I can hit escape on my keyboard. And they're the 2 tapped holes, but I need to position them. So I need a wee bit of construction geometry here. And what I like to use here, just to make it really good, is just a center line from the center of my point out to about there. Okay? Any size. I double click there and cancel that. And then what I'm going to use here, there's a nice wee line I can use. A center line. Oh, it's gone actually. Midpoint line. Okay. I'll go and do another line here, another center line. All right. From here down to there. Okay, so that's from center to center. And then if I pick this end point and hold control on the keyboard and pick that line, see that midpoint coming up? And there's a wee symbol there for midpoint. I can make the two of them coinciding. So I made the midpoint of this line and the end of that line coinciding. So that means that as I put a smart dimension on this, it will both be symmetrical. See that? Because it's the midpoint of the line. Okay, I think it's 70 is the dimension we're looking at. And then we can put a dimension in for the distance out, whatever that was. I want to say 120. I just forget the exact size. Okay, and that should allow us to rollers. So by doing that sketch there, I basically get to position the holes in where I want to position them. All right, and again, I can pick these 2 holes, and I can use my mirror command again. And this time I'm only going to mirror the 1. All right, and mirror them over. It kind of makes sense to do the 2 there because these are for the bearing housing that's going to sit down on it. Okay. Then the last thing I'm going to do there is just to chamfer the edges of the parts in 3D. I normally leave these to 3D. Again, the chamfer is only just a feature. It's not critical, but we don't like to leave the corners of the plates sharp. So just pick the 4 corners there. Make sure you have full preview on so you can see what's happening. And about 10 millimeters is fine. It's 10 by 45. So that's it. So make sure you save the part. Just go that A. Save. All right. With that saved there now. So we can do a quick drawing of that when we're at it. So I can do a new drawing from part assembly or a new one. So I'm going to do new because I have a manufacturing title block here. And again, I can go to my view palette and pick the drawing I want to use, the one we're after doing. And I can drag in, this is the main view of the drawing. Okay. And what I want to do there is I want to make sure I'm in first angle projection and the scale is right. So if I right click on sheet 1, hit properties and make sure it's in first angle, which it is, and adjust the scale. Maybe if it's 1:5, maybe make it 1:3. If I get it wrong, I'll just go back in and do it. Okay. So it got a bit bigger there, but not big enough. So again, right click properties, and I'm going to say 1:2. I'm going to go 1:1. Okay. And that's probably a wee bit too big. So again, don't be afraid to change it. Properties, I'll do 1:1.5. And that doesn't look too bad. I can just do a elevation of that. I don't think much need to do a section view or anything like that. Just like that there. Okay. And again, I need to do my smart dimensions, and I typically do the thickness of the plate. And I can take a corner here to be my reference. And what I'm going to do is I'm not going to do standard dimensions here. I could use a baseline dimension or I could use an ordinate dimension. So for likes of these holes, I like to use ordinate dimensions. All right. So I'm going to leave this bottom left-hand corner as my 0. So this is 0. And then all I need to do is do hole number 1, hole number 2, hole number 3, hole number 4. So that's kind of the X coordinates. That's okay. And then I'm going to do ordinate dimension vertical, which will give me my Y coordinates. So there's my 0. There's one Y, there's another one, there's another one, and there's another one. And that's it. So it's really just for the holes. And then I'd use my normal dimensions then for the overall length of the plate. And then I'd use, obviously, for the overall height of the plate. Okay. And I have the advantage that I use the hole wizard. So I can use the hole call out. And I can pick that hole. And it knows there's 4 holes, diameter 6. That's the 4 holes in the middle. And then these 4 holes in the outside are a different pattern as well, but the exact same detail. So it's 4 and 4, which would be kind of okay to do. And the last thing I would do is just the chamfer here. I just dimension the chamfer. So 10, okay, by, you can do 10 by 10 or 10 by 45 and use the wee degree symbol and hit OK. So that'll be the drawing done. We have to fill in the title block with our titles, our properties and all that. We want to space our views as well. Okay, make sure they're in the center of the sheet and they're a good scale, all right? And make sure you save your file. Same name as your CAD model.